Hi, in this video we are going to design inlet culvert with inlet depression. Okay, inlet depression is provided when you need yeah, high there is any high head water, so you have to provide the inlet depression to accommodate the high head water flow. Okay, so this is the if you want to read in details, so there's SDS 5 code, so you need to read it. Okay, so you will get everything about this culvert. As you can see over here, this is the stream bed and the 1 meter the depression slope, or 1 meter or 2 meter, whatever you are going to provide it, so you need to construct it. Okay, so as you can see, so this is the stream bed slope, and T is the depression height, and D is the width of the depression, and this is the 2T, that is 2T, this length is 2T. And as you can see over here, and this is the width, and T plus 40 is minimum width of the depression. That's called crest width. Okay, crest width is called. So as you can see, we are going to work on this one. Okay, this is the discharge, this is design discharge, and this is the maximum discharge. This is the bottom width of the channel, this is the channel slope, this is the uh, manning value, and this is the invert elevation of the channel, and this is the roadway data we have provided. Okay, and this is the we are going to design concrete box culvert, so this is the size of the culvert we have considered. Okay, and this is the inlet configuration we have used. The square is 90 and 50-degree flare or wing balls. Okay, and this is the inlet depression we have selected, yes or no, we are going to provide yes. So this is the depression 1000 mm, and that means 1 meter, and side slope is 2 to 3 range is the range of this depression slope we have to provide. Okay, so 3 is to 1 we are going to provide, and this is the crest width as you can calculate it by D plus D is the total width of the culvert plus 4 into depression height. Okay, so it's the 10 meter minimum is written is over that minimum 10 meter, minimum the D plus 40, so you can make it more. Okay, that should be minimum, and this is the side data of the culvert. Okay, so don't think this is the computed slope is 15% is coming, so that's not a slope for the your culvert. When you will analyze it, okay, so you will see this is the your geometry 101.5, and this is 5% slope is coming, so that is eligible because 10% is the maximum range of the maximum range to provide this slope for culvert. Okay, so this is the culvert length, this is the culvert outlet elevation, this is a culvert inlet elevation. As you can see over here, the culvert inlet elevation, we have just this is the side data, this is not the culvert invert elevation. So that's why we have provided 1 meter depression, that's why it will minus from this inlet elevation, and you will find out your actual values. Okay, as you can see over here. Okay, and then you can see your graph is also good performance graph. Okay, you just need to see what's the difference we are getting. We need to optimize t 0.92. Okay, we need to optimize it, we need to make 0.12, so we can sorry, first of all we just need to see its front view culvert, that is 5 spacing point 3. Okay, so we can reduce the height. Okay, but it should be less than 1.2, so that is the optimized channel. If you are able to achieve 1.2, that will be very okay to achieve your optimized size of the culvert. Okay, you can reduce the size of the culvert, so you will get it. Okay, thank you.